Expecting you put it where the sun is, it would loosen up to the circle of Jupiter, a beast absolutely precarious and going to detonate. They are among the most detectable effects of radio energy in the whole universe, conveying more energy than a billion suns. UG-Ju, or the surprising Crawley-Ju, is a red giant star. If you put it where the sun is, it would reach the circle of Jupiter, colossal, totally conflicting, and also going to detonate. When we contemplate stars, we no doubt imagine glittering objects in the night sky. This is how we see them from down here on Earth. Yet, stars are something entirely different, perhaps one of the most remarkable wonders in the universe. Betelgeuse, also spelled Betelgeuse, is one of the most striking stars, far more significant than our Sun. For a long time, this star has baffled generations, and, in all honesty, something extraordinary and alarming has been occurring with Betelgeuse, making astronomers and other highly skilled scientists deeply concerned. Join us in this discussion as we explore the groundbreaking new data about Betelgeuse, its impending destruction, as predicted by the James Webb Space Telescope, and what this new development means for our universe and our lives on Earth. According to physicist Michio Kaku, Betelgeuse is a massive wonder, a giant star that has fascinated astronomers for ages. A Greek astronomer named Antonius was the first to discover it. This star is so enormous that it can be seen in the night sky from Earth, especially during winter. If you're into astronomy, you've likely seen or heard about this star. The glowing orange star marks the upper left shoulder of the Orion constellation. This star is ancient and remains one of the most magnificent objects in the night sky. However, one peculiar thing about Betelgeuse's brightness is that it doesn't stay consistent. It fluctuates. This variability is one of its exceptional properties, but it is not its only unique feature. Let's delve into some of Betelgeuse's remarkable attributes. Most stars you see in the night sky are incredibly far from Earth. The closest star is 4.2 light-years away. If you consider what a light-year represents, a distance light travels in 1 year at 186,000 miles per second, it translates to billions of miles. So, when we say the nearest star is 4.2 light-years away, it means it's still billions of miles from Earth. Some stars are even farther, and Betelgeuse is one of them. Betelgeuse is approximately 600 light-years away. Traveling to it at the speed of light would still take 600 years. We can't move that fast. Not even our fastest space rockets can. Yet, Betelgeuse still shines brightly in our night sky. If you're wondering how Betelgeuse can be so visible despite its vast distance, it's due to its exceptional traits, like its size and brightness. Betelgeuse is many times more massive than our Sun. Its diameter is estimated to be hundreds of times greater than the Sun's, and it appears as a disk in space when viewed with current telescopes, unlike most stars that appear as small points of light. This is believed to be due to reactions occurring in the outer layers of its atmosphere. Regarding mass, Betelgeuse weighs around 12 to 19 solar masses. A solar mass is the standard unit of mass used by astronomers, equivalent to 2 times 10 superscript 3 kilograms. Experts cannot determine the exact mass of Betelgeuse because there are no planetary bodies orbiting it to provide a comparison, and we can't measure it directly from Earth. However, Betelgeuse is many times heavier than our Sun. Its brightness varies between a magnitude of plus 0.0 and plus 1.6. In simpler terms, Betelgeuse is typically brighter than our Sun, which is why it is nicknamed a red giant. However, Betelgeuse's nature is not stable. It fluctuates due to its pulsations. In other words, Betelgeuse expands and contracts. When it expands, it gets brighter. When it contracts, it dims. This cycle can last from 10 to 100 days or even longer. A fascinating property of Betelgeuse is that its surface is covered with dark magnetic spots. The magnetic field here is significantly stronger than at its typical surface. However, these strong magnetic spots slow the movement of hot gas to the star's outer layers, making those regions cooler. Betelgeuse has so many of these spots compared to our Sun, which explains why it is cooler despite its size and brightness. The Sun also has its own magnetic spots, but those on Betelgeuse are much larger and significantly more numerous. To give you an idea, the spots on Betelgeuse can be twice as wide as Earth. Betelgeuse boasts a magnetic field thousands of times stronger than that of the Sun. This field is the reason gases on Betelgeuse's surface appear to be swirling or rotating when observed through a telescope. Betelgeuse has a surface temperature of approximately 3,500 K. This low temperature contributes to the low energy output of the star and its faint red color. Betelgeuse is a red star, but it wasn't always red. Around 1 million years ago, it was yellowish, similar to our Sun. Over time, its color began shifting to orange-red, and approximately 40,000 years ago, it gradually transitioned into the red star we see today. This fact has led scientists to believe the star is aging. Betelgeuse produces several times more energy than the Sun. It would have been a fierce competitor to Earth's Sun if it were closer. The fact that Betelgeuse, which is 600 light-years away, can still be seen and recognized with the naked eye at night is truly remarkable. Our Sun is only 8.3 light-minutes from Earth, which is why it's so powerful. If Betelgeuse were closer, we would also be able to see it during the day. However, if it somehow replaced the Sun, it would engulf or displace Earth and the other 4 planets near it due to its massive size. Even if it matched the Sun in size, it would still emit far more radiation. Betelgeuse, also known as Betelgeuse, is a supergiant star located in the Orion constellation, approximately 600 light-years from Earth. Its massive size is one of its most notable characteristics. It is significantly larger than our Sun and, if placed at the center of our solar system, would easily extend to Jupiter's orbit. This immense size allows Betelgeuse to appear as a disk rather than a point of light when viewed through powerful telescopes, unlike most other stars. Despite its enormous size, Betelgeuse is not the largest star. Its mass ranges from about 12 to 19 times that of the Sun, and this variation in estimates arises from the difficulties in accurately measuring the mass of stars without companion objects for gravitational reference. Even at its lower estimated mass, Betelgeuse remains a colossal celestial body. Its brightness, another defining characteristic, fluctuates over time, ranging from magnitude 0 to plus 1.6. For comparison, a magnitude 0 star is one of the brightest visible stars in the night sky, while a magnitude plus 1.6 star is still relatively bright but less luminous. This variability in brightness is due to Betelgeuse's pulsations, where the star expands and contracts over periods of time. These pulsations not only affect its brightness but also contribute to its unique behavior as a variable star. Betelgeuse's red color and immense size suggest that it is nearing the end of its life cycle. As a red supergiant, it is expected to eventually explode in a dramatic supernova. When this happens, it will outshine the entire galaxy for weeks or even months. The explosion will produce a dazzling display visible from Earth, even during the day. Astronomers predict this could happen any time within the next 100,000 years, a relatively short time in cosmic terms. The impending supernova of Betelgeuse is not expected to pose a direct threat to Earth due to its distance of 600 light-years. However, it will provide valuable opportunities for scientists to study the life cycle of stars and the processes involved in supernovae. The aftermath of such an explosion will likely include the formation of a dense neutron star or possibly even a black hole, depending on the star's final mass before collapse. For now, Betelgeuse remains an object of fascination and mystery. Its variability, size, and eventual fate make it one of the most studied stars in the universe. With advanced instruments like the James Webb Space Telescope, astronomers are continuously monitoring this star, hoping to capture new insights into its behavior and eventual demise. In conclusion, Betelgeuse is more than just a bright red star in the night sky. It is a cosmic giant, a beacon of change, and a reminder of the immense forces at play in the universe. As it continues to captivate astronomers and stargazers alike, it holds the promise of unlocking new knowledge about the cosmos and our place within it. In addition to one star at its most brilliant, Betelgeuse can be a few times more radiant than our Sun. This change is credited to its throbs, discontinuous expansions and contractions, achieved by internal cycles within the star. When Betelgeuse expands, it becomes more luminous. When it contracts, it dims. These throbs can last for a significant period, adding to its dynamic appearance in the night sky. Betelgeuse's surface temperature is moderately low for such a gigantic star, measuring around 3,500 Kelvin. This gives it a distinct red tint, typical of red giant stars approaching the end of their life cycles. Like other red giants, Betelgeuse is in the late stages of stellar evolution. It has exhausted the hydrogen fuel in its core and has begun fusing heavier elements. This fusion process produces energy and causes the star to expand outward. The star's atmosphere is rich in complex physical phenomena, displaying dark magnetic spots on its surface where the magnetic field is stronger than the surrounding regions. These spots prevent the convection of heat, leading to cooler regions on the surface. Despite these cooler spots, Betelgeuse remains a colossal, brilliant star. However, it will eventually meet its end in a spectacular, catastrophic explosion. Betelgeuse, a massive star nearing the end of its life, faces a dramatic fate. When it runs out of fuel, it will undergo an extreme process of fusion, creating heavier elements like helium and carbon. This will cause the star to expand to even greater sizes, possibly becoming one of the largest stars in the night sky before it dies in a massive explosion. A supernova. The power of a supernova is strong enough to obliterate an entire system, sending shockwaves through space. Scientists speculate that Betelgeuse could experience such a dramatic end relatively soon, though the exact timing is uncertain. As Betelgeuse approaches the end of its stellar life, astronomers are closely monitoring its behavior. The star is expected to go supernova eventually, an event that will result in the ejection of its outer layers into space, leaving behind a dense core. This core could become a neutron star or collapse further into a black hole, depending on its mass. A supernova is a cataclysmic event signaling the final stages of a star's evolution. Betelgeuse's potential supernova could be visible from Earth without a telescope, given its immense brightness and proximity. This explosion would release vast amounts of energy, creating heavy elements like iron and nickel, essential for the formation of planets and other celestial bodies. These elements would scatter throughout the universe, enriching the interstellar medium and contributing to the formation of future generations of stars and planets. Interestingly, researchers have detected unusual changes in Betelgeuse's brightness in recent years, leading to speculation that the star might be nearing a supernova. However, despite these fluctuations, it is challenging to predict precisely when the star will explode. Some scientists suggest that Betelgeuse could go supernova within the next 100,000 years, a brief period in the life of the universe, yet far too distant to pinpoint the exact time. The James Webb Space Telescope, JWST, has provided new insights into the star's behavior. Its infrared capabilities allow researchers to study Betelgeuse's outer layers and magnetic fields in unprecedented detail. JWST's findings have confirmed the star's ongoing changes, including its erratic brightness and potential instability. These observations offer crucial data about the processes leading to a star's demise, enhancing our understanding of stellar evolution. Betelgeuse's death will have wide-ranging implications for the universe. The supernova shockwave could potentially trigger the formation of new stars in the surrounding region, supporting the cycle of stellar birth and death. Furthermore, the elements created by the explosion will spread throughout space, contributing to the building blocks of new planetary systems. In the grand scheme of cosmic evolution, Betelgeuse's death will not only mark the end of one of the largest stars observable, but also pave the way for the next generation of celestial objects. Although we won't be around to witness the star's final moments, the study of Betelgeuse provides valuable insights into the life cycles of stars and the dynamic nature of the universe. The research conducted on this star helps astronomers better understand the processes that govern stellar birth, life, and death. It offers a glimpse into the fate of other stars with similar characteristics. In the future, scientists hope to continue studying Betelgeuse with cutting-edge technologies and space observatories. The information gathered from this star will continue to shape our understanding of astrophysics, helping us unlock the mysteries of how stars evolve and what their violent deaths mean for the universe. All in all, Betelgeuse, as an enormous and dynamic star, is a vital piece of the cosmic puzzle. Its eventual destruction will be one of the most fascinating events in the history of our universe. While Betelgeuse's death is inevitable, it is important to remember that the universe is constantly changing and evolving. As Betelgeuse nears the final stages of its life, astronomers continue to collect critical data on its behavior and potential supernova event. Understanding its evolution will provide valuable insights into the broader processes that shape the universe. Stars like Betelgeuse, approaching the end of their life cycles, undergo dramatic changes that offer astronomers a unique opportunity to study stellar death up close. The massive release of energy from the supernova will illuminate the surrounding space for a brief period, allowing scientists to observe the intricate processes involved in a star's death. Moreover, the elements created in a supernova, such as heavy metals like iron, carbon, and oxygen, are essential for the formation of planets and life. These elements are dispersed throughout the universe by the shockwave, enriching the interstellar medium and providing the building blocks for new stars and planetary systems. This process plays a crucial role in the ongoing evolution of galaxies and planetary systems. One of the most fascinating aspects of studying stars like Betelgeuse is the insight it provides into the fate of our own Sunday. While our Sun is much less massive and will have a different fate, studying massive stars like Betelgeuse helps scientists understand the potential outcomes for other stars in the universe. These findings can inform our understanding of stellar populations and how they evolve across cosmic time. Additionally, Betelgeuse's potential demise will highlight the dynamic and ever-changing nature of the universe. Although we won't witness this event in our lifetimes, the information gathered from Betelgeuse will continue to influence scientific thought for generations. The study of such massive, evolving stars will remain a fundamental part of astrophysical research, helping to unlock the mysteries of how stars live, die, and shape the universe. The study of stars like Betelgeuse also enhances our understanding of the larger cosmic cycle, which encompasses the birth, life, and death of stars across the universe. By examining how massive stars undergo their final stages of evolution, scientists gain insights not only into their individual life cycles but also into the broader patterns of stellar dynamics. This understanding is essential for studying galaxy formation and evolution, as stars are fundamental building blocks in the development of galaxies over time. Alongside ongoing astrophysical research, the study of Betelgeuse's potential supernova will provide a better understanding of the types of radiation and cosmic events that influence nearby stellar systems and even the intergalactic medium. When a star like Betelgeuse goes supernova, the sheer power of the explosion can impact surrounding space, triggering the formation of new stars or disrupting the balance of neighboring star systems. The aftermath of the explosion is critical for the universe as a whole. The debris from the explosion, including heavy elements, will spread throughout space, potentially influencing the composition of nearby nebulae and facilitating the creation of new planetary systems. This cosmic recycling process plays a critical role in the ongoing evolution of galaxies and will shape the formation of future celestial bodies for billions of years.